Welcome of all. Now we are going to start third application of Gauss theorem. Electric field due to two parallel infinite plane sheets of charge. In second application we have calculated electric field intensity due to infinite plane sheet of charge. So now we will use that application in this third application. So here in the diagram we have placed two parallel plates vertically parallel to each other. In this way, these are the two parallel plates which are placed parallel to each other vertically, and positive charge is distributed uniformly over these two parallel plates. Suppose this plate having surface charge density sigma 1 and this second plate having surface charge density sigma 2, and this is the direction, x-axis direction, that is these two plates. Due to these two plates we have electric field, and this electric field that is directed along x-axis. It will be along positive x-axis and negative x-axis. This is a positive x-axis and this is a negative x-axis. So in between, now we are going to calculate electric field in three regions of these two parallel plates. This is the first region, this is the second region, and this is the third region where we are going to calculate the electric field intensity due to these two parallel plates. So for this we will take one case that suppose this sigma 1 is greater than sigma 2, that is the surface charge density of A plate is more than that of B plate. So this plate having more electric field, suppose this plate electric field E1 that is more than that of E2 due to this surface charge distribution. So in this region, suppose we want to find out the electric field at this point. So here the direction of electric field is toward this side, E1, and at this point the direction of electric field is due to this B plate also this side, but of less magnitude, because that is a one lying very far away from this A plate and having less magnitude of charge because sigma 2 is less. So that is represented with the small size of arrow. This is E2. Now come to second region. This is the point. Suppose we want to find out the electric field. So in this region, the electric field due to this A plate, that is E1, away from this plate, that is toward positive x-axis, and due to the second plate that is also away but toward negative x-axis, and that is with a small size of arrow. Now come to this third region. Suppose this is the point where we want to find out the electric field. In this region, due to this charge, electric field is toward positive x-axis but with small arrow size, and due to this A plate, this is direction of electric field E1, this is E2. So these are the direction of electric field. Now here E1 and E2 along x-axis, positive x-axis, here E1 and E2 negative along negative x-axis, here E1 is along positive x-axis, E2 toward negative x-axis. Positive x-axis taken with positive sign and negative x-axis taken with negative sign. We remember this. Now mathematically, now we will find the electric field intensity in first, second and third region. So firstly we know that electric field intensity due to infinite sheet of charge at any point is E sigma upon 2 epsilon naught. This we have studied, but here we are taking the direction, so be the direction here vector quantity and here vector unit vector, that is I, taking along x-axis. So with the help of this equation, we will find out the electric field intensity in first and second and third region. So in first region, this is the first region, the net electric field is, that is E1 plus E2, but the direction is both along negative x-axis. Then we write minus E1 plus E2. I think this is clear. Now we will put the value of E1 and E2, because this negative sign indicates net electric field is toward negative x-axis. So here negative sign come outside. So here we write sigma 1 upon 2 epsilon naught plus sigma 2 upon epsilon naught. This is the, and here unit vector I. This is the net electric field in 1 upon 2 epsilon naught is common. Then we write sigma 1 plus sigma 2 along negative x-axis. This is the net electric field in first region. Electric field in the first region. Now in second region, electric field intensity is, now in the second region, you see this second region, that E1 is along positive axis and E2 is toward negative x-axis. Then we'll write sigma upon 2 epsilon naught with and minus sigma 2 upon 2 epsilon naught. We will write 1 upon 2 epsilon naught sigma 1 minus sigma 2, and this is direction unit vector. This is electric intensity in the second region. Now come to third region. In third region, electric field intensity. Now you see in this region the electric field intensity is toward positive x-axis. So here we write the sum of these two electric fields, E1 plus E2, that is equal to sigma upon 2 epsilon naught sigma 2 upon 2 epsilon naught. So here 1 upon 2 epsilon naught common, sigma 1 plus sigma 2 is. So in these three reasons we have calculated the electric field intensity. Now we will take one special case. For two equal and opposites surface charge densities, that is sigma 1 is equal to sigma, sigma 2 is equal to sigma. These are the two equal intensities, but here written opposite. So let us suppose sigma 2 is a negative. Sigma 1, that is equal to sigma, sigma 2 is equal to sigma, but with opposite sign. So let us suppose sigma 2 is with the negative sign. These are the intensity, two equal and opposite intensities. Then in first region, electric field is, in first region electric field intensity is this. This is the electrical intensity in first region. This is, then we will write minus 1 upon 2 epsilon naught sigma 1 minus sigma 1, that is sigma, that is equal to 0. In first region electrical intensity is 0. In second region 1 upon 2 epsilon naught sigma minus sigma, that is equal to sigma upon epsilon. In this is in the second region. And in third region 1 upon 2 epsilon naught sigma minus sigma, that is equal to 0. So in this second region, the electric field, that is equal to sigma 1 upon epsilon naught. Here sigma 1 upon epsilon naught. That in second region, this second region we can explain as this is a positive charge plate and this is the negatively charged plate. Here sigma surface charge density, here sigma charge density, and you know that the direction of electric field, that is from positive to negative charge, positive to negative charge, positive to negative charge. So here we have a uniform electric field intensity, that is equal to sigma upon epsilon naught. This is a very important result, a lot of use when we'll study about the capacitors. So this, you know, the from here we come to know that between the two parallel plates electric field that remain uniform, constant, and its magnitude is sigma upon epsilon naught. Thank you very much. Stay safe at home. Take care of yourself. Thank you.